Today's lecture topic is simultaneous heat transfer mechanisms. We mentioned that there are three mechanisms of heat transfer, but not all the three can exist simultaneously in a medium. For example, heat transfer is only by conduction in opaque solids, but by conduction and radiation in semi-transparent solids. Thus, a solid may involve conduction and radiation, but not convection. However, a solid may involve heat transfer by convection and radiation on its surface exposed to a fluid or other surfaces. For example, the outer surface of a cold piece of rock will warm up in a warmer environment as a result of heat gained by convection and radiation, but the inner parts of the rock will warm up as this heat is transferred to the inner region of the rock by conduction. Heat transfer is by conduction is possibly by radiation in a still fluid, no bulk fluid, and by convection and radiation is a flowing fluid. In the absence of radiation, heat transfer through a fluid is either by conduction or convection, depending on the presence of any bulk fluid motion. Convection can be viewed as combined conduction and fluid motion, and convection in a fluid can be viewed as a special case of convection in the absence of any fluid motion. Thus, when we deal with the heat transfer through a fluid, we have either conduction or convection, but not both. Also, gases are practically transparent to radiation, except that some gases are known to absorb radiation strongly at certain wavelengths. Ozone, for example, strongly absorbs ultraviolet radiation, but in most cases, a gas between two solid surfaces does not interfere with radiation and acts effectively as a vacuum. Liquids, on the other hand, are usually strong absorbers of radiation. Finally, heat transfer through a vacuum is by radiation only since conduction or convection requires the presence of a material medium. Question is, heat transfer in conventional and microwave ovens is the fast and efficient cooking of microwave ovens made them one of the essential appliances in modern kitchens. The heat transfer mechanism associated with the cooking of a chicken in microwave and conventional ovens, and explain why cooking in microwave oven is more efficient. The answer is, for this problem, food is cooked in a microwave oven by absorbing the electromagnetic radiation energy generated by the microwave tube called the magnetron. The radiation emitted by the magnetron is not thermal radiation, since its emission is not due to the temperature of the magnetron, rather it is due to the conversion of electrical energy into electromagnetic radiation at a specified wavelength. The wavelength of the microwave radiation is such that it is reflected by metal surfaces, transmitted by the cookware made of glass, ceramic or plastic, and absorbed and converted into internal energy by food or molecules. In a microwave oven, the radiation that strikes the chicken is absorbed by the skin of the chicken and the outer parts. As a result, the temperature of the chicken and near the skin rises. Heat is then conducted toward the inner parts of the chicken from its outer parts. Of course, some of the heat absorbed by the outer surface of the chicken is lost to the air in the oven by convection. In a conventional oven, the air in the oven is first heated to the desired temperature by the electric or gas heating element. This preheating may take several minutes. The heat is then transferred from the air to the skin of the chicken by natural convection in most ovens, or by forced convection in the newer convection ovens that utilize a fan. The air motion in convection ovens increases the convection heat transfer coefficient, and that decreases the cooking time. Heat is then conducted toward the inner parts of the chicken from its outer parts in a microwave oven.